and economies worldwide. The theme, Beat Plastic Pollution, calls for urgent action to shift from a linear to a circular economy. At CSIR-NEERI, every day is a committed to sustainable science. But today, we amplify our collective voice for a cleaner, greener, and more resilient planet. Alongside, we also commemorating National Technology Day, which marks India's technological advancements and scientific innovations. Originally, it was celebrated on 11th May to honor the successful Pokhran nuclear test, but today we are observing it as part of this combined celebration due to schedule constraints earlier.
Yeah, I know. See.
We are honored to have with us our distinguished guests who are pioneers in their field. We have with us our distinguished speakers and chief guest, Dr. K. Rajivan, who is Vice President and Chief Technology Officer at Larsen & Toubro Water and Effluent Treatment IC. We also will have Dr. P. Ganesh Kumar, who is R&D Head, LNT Water Technology Center, Chennai. Our Director, Sir, CSIR-NEERI, Dr. S. Venkat Mohan, esteemed guests, colleagues, researchers, and students. I request everybody to please give a big round of applause to our chief guest, and I request Mr. Pranay Sumhari, sir, to please escort the dignitaries to the dais. I request Director Sir to present a sapling to our chief guest. A token of appreciation and his gracious presence. Thank you so much, sir. To formally begin today's program, I now invite Director CSIR-NEERI to deliver the welcome address.
K. Rajivan, Vice President, Chief Technology Officer, Water and Effluent IC, Larsen & Toubro, Chennai, Kumbareji, Dr. Ganesh Kumar, Larsen & Toubro, colleagues, guests, and the students. Warm greetings to all of you. On behalf of CSIR-NEERI, I would like to welcome all for the combined celebrations of World Environment Day and National Technology Day. This happened because we have organized a big event in Mumbai on startups, so that has made us to combine both the things, but it has relevance. So first I would like to thank Sri Rajivan ji for taking time in his busy schedule with his short notice of time. He agreed for our invitation, and your presence. To complete, we human consumption. Everywhere we find plastics right now in the form of macro or nano pollutants. So coming to National Technology Day, which we have to observe on May 2011 to commemorate 4.2 on Indian technology achievements. This year, team is empowering a sustainable tomorrow for innovation. So this fits well with the sustainability and innovation, and also fits well with plastic pollution management. So when NEERI is looking into these two aspects very closely and has embedded in its vision, NEERI's mission. So when we look into the plastics, so everybody knows plastic is a major issue globally. At present, India to 430 million tons of plastics produced annually, wherein 2/3 is coming as waste. So adding to that, nearly 12 billion tons of this plastic waste is going to oceans. So when we look into the statistics, only 10% of the plastics is being recycled globally. In specific to India, India produces near to 3.5 billion tons per year, wherein 1/3 remains uncollected. The basic advantage in India is rag pickers who try to segregate plastics even though very lack of protection conditions, and they are the major sector which is helping us to recycle plastics. So, and also India is looking towards moving to extended product responsibility, which will be, this framework is very important, particularly for India, which will be coming up in the near future. So when we look into CSIR-NEERI, what it is doing on plastics, plastic management, it is multi-fold. So just to brief, I would like to keep some points. NEERI is looking into monitoring of microplastics. So microplastic monitoring in the air, soil, and water, significantly it is doing. And recently, one of the publications from Dr. Ramesh Kumar's group showed that in the air of North group, there is presence of LDF, rayon and polystyrene kind of plastics in macro concentrations, macro sizes, not in concentration. And one of the study carried out by Dr. Krishnamurthy group, they try to understand the fate of plastics, microplastics particularly, in sewage treatment plants, and observed there is about 92 correction of plastics when we look into the inlet and outlet. But the major issue is where this plastic is going. This plastic mostly goes to the sludge, so that also needs to be addressed. Apart from that, NEERI is also working significantly on toxicology as well as health aspects of plastics. So Dr. Krishnamurthy group, they are working on fish studies as well as rat models. And their studies show that accumulation of microplastics in organs causing oxidative stress and zero toxicity, particularly in fish experiments. And rat models showed liver tissues accumulation of microplastics and causing mitochondrial dysfunction, liver inflammation, and gene alterations. So plastic waste management and resource recovery is one of the domains where many groups in the area are working very closely. So one of the area is waste to graphene technology by thermal process trying to convert it to graphene, where this material can be used to capture CO2 away or can be used in some kind of medicinal applications. Thermocatalytic conversion is another domain where a couple of groups are working to transfer plastics, different kinds of plastics, either LDF, polystyrene, and PVC into some value-added products, which can be further used into the circular loop. So also, NEERI is working on solar panels. Solar panels, once after its lifetime, recovery of the resource is one of the important things. So in recovering metals, plastic is also one of the important components, and trying to segregate plastics as well as metals in a refined strategy. That is one area. Significant happenings, or I can say significant output has been applied, leading to bigger projects. So CSIR-NEERI is also supporting national policy, particularly you may be aware that plastics, we also have plastic materials also have additives, which are known for its toxicity. And NEERI is, as you all know, it is having Stockholm regional centers for POP and looking into policy in a very significantly. So here, trying to assess the materials, additives which is in the environmental system, or trying to come up with some kind of policy. You may be aware that United Nations Environment Program is going to develop a global plastic treaty, which will be signing by the end of this 2025. So whatever is NEERI is doing in this domain to identify these kind of materials, which is coming from recycled plastic pellets or materials which are known for POPs, it should have a long impact on policy making. So in this domain, particularly, NEERI is also collaborating in multiple global institutes. So one of the important projects I would like to say, Indian-Australia CSIR project, which has tracked the technical aspects for plastic management, particularly polymer-based use. And this has been released on December 2023 by Honorable Minister Dr. Jitendra Singh in a companion National Circular Economy Roadmap for Plastics. So this is one of the important things NEERI has done in a collaborative way to address circularity of plastics. It's also NEERI working with World Bank project via KPMG to understand the plastic pollution baseline in Pulicat Lake, Gulf of Cambodia, and Grenada lakes. Also, scoping study with the Netherlands Embassy, trying to look into the informal sector, particularly that because in Nagpur, Bombay, Ghaziabad, and Muzaffarnagar, to understand how this is influencing the carbon plastic recycling. Also, NEERI is looking into unit project, that's the seasonal plastic profiling to understand hotspots, particularly Nagpur and 4 other cities. So these are the projects which NEERI is trying to understand and try to address the issue of plastics. So as you all know that NEERI is one of the institutes which try to change its mission required by the society, as and when starting from water up to now climate change. In between, plastics is one of the major things, and also NEERI is trying to address it in a very sustainable way. So now I will stop here. And I want to try to, on this day, let's renew our commitment to a greener, and more sustainable future. Let science and innovation drive our environmental action. And thank you all for your kind attention.
Thank you so much, sir, for your visionary words and highlighting different research areas where NEERI is working to achieve sustainability and combating plastic pollution. Thank you for setting the tone today. And now, the most awaited part of today's program, the keynote lecture on the intersection of environment and technology in the modern world. We are privileged to have with us Dr. K. Rajivan. And it's my honor to introduce today's distinguished speaker. He is the Vice President and Chief Technology Officer at Larsen & Toubro, Water and Effluent Treatment IC. With over 35 years of experience in engineering and technology, Dr. Rajivan has been at the forefront of innovation in water and wastewater treatment, as well as hydrocarbon engineering. His contributions span large-scale infrastructure development, cutting-edge R&D, and the application of sustainable technologies. An alumnus of NIT Calicut and BTech in Civil Engineering, Dr. Rajivan is a member of the Institution of Civil Engineers at London and the International Project Management Association. He also serves on the Innovation Committee of FICCI, reflecting his commitment to advancing national capabilities in infrastructure and sustainability. In the water and wastewater sector, he has been instrumental in the engineering of several advanced sewage and water treatment plants, including membrane-based STPs, critical refineries, and international projects in locations such as Doha. His expertise in hydrocarbon engineering includes contributions to refinery and petrochemical projects for organizations such as IOCL, HPCL, MRPL, and Petronas in Malaysia. As CTO at L&T's Water and Effluent Treatment IC, Dr. Rajivan currently leads the organization's research, innovation, and technology strategy with a strong focus on sustainable infrastructure, energy efficiency, circular economy principles, and digital transformation in water management. I welcome you, sir, on the dais and to address the August gathering.
First, to address what to address for some time and then for the presentation is not needed. But you speak for some time.
Very good afternoon, Dr. Venkat Mohan, the Director of NEERI, all other scientists, researchers, students, ladies and gentlemen. It's a great honor and privilege to stand in front of this esteemed gathering of scientists, researchers, innovators, students, PhD students, and all a community of researchers are there here. And I extend my heartfelt thanks to the organizers for inviting me for such a a big celebration of World Environmental Day and National Technology Day. Especially I am there where all of you are environmentalists and with so many years of experience. So I was also just thinking that what is that I can deliver to you, because you already, it's having a wealth of knowledge in environmental area. So what I will do is that I just wanted to speak on the theme which you already mentioned, and then I will also speak on, or I wanted to show a presentation on what L&D is doing in these areas. So we all know that this combating plastic pollution is the theme for this World Water Day, World Environmental Day today. And let me begin by acknowledging the great work being done by NEERI and across the CSIR family in shaping India's environmental research and policy making. I know that all of you are NEERI is doing a big, and it's one of, maybe the biggest institution for that. And as he mentioned, the present situation is that we have huge production of plastic, almost around 400 plus metric ton of, million metric ton of plastics is produced across the world. And out of that, I understand that 2/3 of that is becoming a waste, plastic waste. Only 1/3 of that only we are able to convert the circular economy, like we are able to reuse or the recycle. Balance is going immediately after the single use. It's going as a waste, and finally, as he says, it's going to the river or ocean, and even to our own body, like we are consuming in the form of microplastic. So it's becoming a big health hazard as of today, not only for us, even for the animals and other living things. In India also, I understand that almost around 3.4 million tons of waste. It's a plastic waste is produced now every year. And maybe in another 5 years, it's going to double. That means almost around 7 million metric ton of waste we are going to produce in India itself. And I also could see that out of this 3.4 million ton in India which is produced, in that these three states are producing almost around 35-38% of the total. That is, one of that is Maharashtra, another is Tamil Nadu, and third one is Gujarat. I don't know whether this statistic is correct or not, but if that is there, then I'm from Tamil Nadu, and we are here in Maharashtra. these two states are producing so much of waste. And in spite of all this, we are recycling and reusing, and we almost banned, India banned almost this single-use plastic, and still the waste is keep going up from whatever we had earlier. Now it has become 3.4, and expected is another 3.4 is becoming by 2030. That means every year it's only going and it's not getting diminished. So we need to really look at this crisis, and it's going to be a big crisis. And I am sure that this how can we stop this, or how can we reduce this? Only by, solution is only technology and science only. And I also want to say that since I am here and in front of me, all the scientists and technologists are sitting, so all of you are holding the key for solving one of these greatest environmental challenge of our time. So we need not go out anywhere. It is there in this room itself. So we all know that there are many solutions already found, like garbage bag. I remember even in my the complex of our residential complex. Earlier we were using the plastic. Now we all converted that to biodegradable. So like that, there are changes, but we are not able to see that reflection in our total wastage formation. So it's only keep going up. So there are many other solutions which is already found, like biodegradable alternative, enzyme-based plastic degradation, and then this pet bottle itself now, PTase is one of the enzymes which is now used for degrading that, biodegrading that. So many things are coming up, and even the AI-based waste management system is in use in many places, many cities. As I mentioned, circular economy is already in place, and some of the other promising directions are like bioplastic from agricultural waste, smart sorting and recycling by robots. Even in India, I heard in some of the cities this is in place. Similarly, algae-based and fungi-based decomposers. So many things are in place, but the situation is that is not sufficient. So we need to do something still more. That is where we can only depend on the scientists and the science and technology only. I just wanted to call upon these young scientists who are here, maybe the PhD and just doing it, who is thinking about the future. They can do a lot of things because they are born in plastic age. And then I just wanted to say that they don't have to inherit the plastic future also, because they need to find a solution. And probably the solution is not just only science and technology, because it's also a mindset. Because we know that when this plastic was invented, it was something like a miraculous invention, where it is more durable and it is having high strength. In some cases, very weight-wise, it is very much low weight. So it can be shaped in any shape what we want. So it was having a lot of good features. That is how this has come up, and then even in L&D's using even for our the homework and other areas also now plastics, because it has become easy to transport. So many plus points are there. So that is how it keeps going up. But we cannot now allow that to happen. So we need to see that only whatever it can be reused, only we should use it, and this need to be dumped, we should avoid now using it. See, it cannot be done by only one discipline. It has to be a combined effort of various disciplines, and probably the psychologists, and all has to come together to understand that how to put this in the mind of the people that we should not use this plastics, especially the single-use plastics. Though we are having ban and all, but I am finding that everywhere it's available now. So we should go for linear to circular. We should go for convenience to which was our convenience earlier, we have to go for consciousness, the competition to collaboration. As a society, we must shift our mindset from exploitation to coexistence. We also understand that nature is not a resource to be consumed, but it's a legacy to be preserved. So before I conclude, I just want to say, leave one thought in your mind. We do not inherit the earth from our ancestors. We borrow it from our children. So let us not just act for today, but it's for generations to come. From this, I also wanted to just show you what L&D has done for avoiding many of the issues related to environment. So, just wanted to know it. Okay, no problem. Great. There are some technical features are there. Before it is getting ready, I also just wanted to talk about so that I can reduce the time there. So L&D, we have got around 9 or 10 vertical business. In that, one of the vertical is L&D wet or L&D water, which is we are doing a big business in that field also. Almost around 15,000 crores per year is our sales. So some of our activities or business in that is, one is water supply, that is from the river, the source to the end user, the consumers, through the intake, then there will be water treatment, then there will be pumping, then it is sent to the individual houses. And then within the city, we have an urban water system where water management is very important, 24/7 water. And then other areas, especially this irrigation, that is one of our big business, because the water requirement is very high for farmers, and especially in states like MP, Odisha, Karnataka, and all, there's a lot of shortage in the farmland water. So that is another big business where we are doing it, where the business we are doing it for a bigger scale. Then another area what we are doing is a treatment business, especially wastewater, water treatment, industrial water treatment, industrial wastewater treatment, desalination plants, and many more similar treatment plants we are working on. So all these areas, what we are working, we have a team starting from engineering till commissioning, and then including the operation and maintenance. So we are there in the complete spectrum. So we have a complete in-house engineering team. Almost we have around, for water alone, we have around 600 plus engineers for various disciplines working for engineering. Then we do procurement, then we do execution, then the construction, then we do commissioning, then the next is operation and maintenance. So complete system we are having it. Let's start now. Ready?
Yes.
Yeah, so welcome for my presentation here. This is I just mentioned that we are also there in the international area, international, some of the countries with our projects, the EPC projects. And bottom you can see we are also having an R&D center, but it's called Water Technology Center. You can see here. And we have around 29 qualified postgraduate research scientists there, along with 10 PhDs. This has come up only 3 years back. So the basic reason was that there are a lot of technology which is becoming obsolete slowly. So we wanted to come up with some new technology, enhancement for the existing technology, and also thinking about the futuristic technology. So that was the idea to come up with this R&D center. This I already mentioned that these are all the countries where we are working. And in India, you can see almost around 80% of the states we are there with the EPC projects. This also I just mentioned that the scheme for water supply. Then this is for the scheme for irrigation projects. You can see from reservoir till the farmland with the various pumping and other activities we are there. And here also, I can say that the water, we are also now controlling with the AI/ML technology that the minimum water required for each crop and each season. So we are working on that also. So otherwise, we'll be pumping so much of water, and sometimes some of the crop may not require so much water. Some crop may need more water. Some of the season you may not require more water. So those requirements, by using AI/ML technology, we are now trying to optimize so that the water required for those crops can be reduced. This is the municipal wastewater, starting from collecting from the individual house up to the wastewater treatment plant. There is a municipal wastewater, and then including the power generation and the one which is treated, it is disposed of. We are also doing the reuse in some of the plant, and this is the some of the clients what we have. You can see most of the government clients, state boards, and other side you can see this all are international customers. It's government as well as privates are there in that. And then you can see, the policy makers, which anyway all of them you are aware of that. And right side we have the consultant, starting from international consultant to Indian consultant. This is our track record. We have done water treatment plant of around 10,000 MLD, then desalination plant of 120 MLD, then wastewater treatment around 2,800 MLD, then pipeline we laid around 5 lakh kilometer for supplying water, and for irrigation we have done around 1.1 million hectares, and then the Class A sludge, which is now becoming a requirement because the sludge disposal is becoming a problem. So they wanted to convert that as a Class A sludge. Around 496 MLD, we are doing it. We have done it, brother. And this power generation. So earlier, all the STPs, the power was from the grid. Now they wanted to use the They wanted to generate the power from the gas itself, which is generated from the sludge. So 815 MLD plant, which is constituted around 3 or 4 sewage treatment plant. We are doing power generation. So we are able to do almost around 50% of the power requirement can be made from this sludge itself. Then the other right side, you can see the industrial water treatment. We have done around 215 MLD. This is some of the photograph of our projects. This is our capability. You can see from, as I mentioned, from design, we have around 600 plus. Actually, I was heading this engineering for some time earlier. And then we have advanced, we have the construction techniques, some team we have separately who works on how it can be done faster and very safely. Then we have an integrated project management team. Then entire thing now we digitalize, like it's completely integrated from design to the end, including the O&M. Both the BIM as well as the construction activity we have digitalized, including the P&M we digitalized. So you can say more or less fully digitalized the whole activity. Then here I will just spend some time. This is a technology which we are having now for water supply and treatment. This precast technology is something you know that it's a concrete technology where you can do casting of concrete faster, like you make it ready-made somewhere and then just place it in one place. So balance are all related to water, like we are there doing ozonation, we are doing ultraviolet, similarly dissolved air filtration, membrane filtration, membrane is ultra, micro and nano, then granulated activated carbon, then desalination area, as I mentioned, we are there, RO, ultra filters, split partial techniques. Then industrial water treatment, we have the ultrafiltration, reverse osmosis, ozonization, electrochlorination, dissolved air flotation, zero leakage discharge. Then for water management, we created a digital team for how to reduce the NRW, so make it more automated thing. Then 24/7 water supply, smart water management. Irrigation, as I mentioned, to bring down the use of water, like optimizing the water use. We have a outlet management system. Then the entire thing we have done it through GIS, so we are able to reduce the length of the pipe because we are able to bring it to the shortest distance possible, and the diameter of the pipe also we are able to reduce through this GIS. Wastewater treatment, we have AGBR. This is our own technology, attached growth bioreactor. Then we have our own LND SBR. Then membrane bioreactor, we have done wastewater treatment, especially in Mumbai, it is going on now. Then anaerobic and anoxic, that is A2O technology. Then extended aeration, then MBBR. Then sludge treatment, the one which we are doing it in some 2 projects, that is a TPAD for class A sludge, which I just mentioned. This is the engineering capability part. You can see that we have the complete spectrum of engineering discipline, team, and then it is complete. We have all these softwares, and it's, as I mentioned, it is completely automated now. It's all engineering is through BIM. Then this is a totally integrated digital system for starting from engineering till commissioning. We'll be able to online, we'll be able to see what is the status of each project, what is the status, what is the problem they are facing. So you can see it's completely automated, including the quality, including the safety, plant and machinery, IoT-based plant and machinery. The whole system is now automated. We have around 18 plus solutions, initiative for that. These are all the success stories like the Mumbai project, what we have done to the right side, the STP for A2O projects, what we have done in Delhi. This photograph probably you would have seen earlier that this Uttarakhand tunnel rescue mission, LND was part of it. LND water was part of it. Then right side, this is a robotic camera we have used for finding out the problem inside the pipeline. Inside the pipeline, water flow is reduced. Maybe because of something else put inside, or sometimes the pipe would have got damaged. So just to find out that, we started using now the robotic camera. This is some of these awards. There are also awards. And this comes to the Water Technology Center. This is what I said, till whatever I have shown you, it was there for last 20-25 years. That time we were not having a separate team for R&D. So this 3 years back, our chairman has decided that we should have a R&D team separately to take care of water specific research. We were having an R&D center general, but we wanted to specifically have a R&D center for water. So this is their mission. So I'm not reading it out. This is our Water Technology Center. Our main principle is we have to measure we have to analyze physical, chemical, biological characteristics, and similarly all the data we need to collect based on our O&M. So another day we have an O&M plan. So we keep getting the data from the, like, what is the inlet quality of water, what is the outlet quality of water, and then we can verify that what is happening and why some places it is different, why in some other project it is different. So we are able to do that analysis, and then we have a R&D team to see that how to enhance those process, how to come up with some new technology. So the team, R&D team, is working on that. Then the third one is how to sustain, like we come up with some new product, but how to implement it, how to sustain that. So we work with our business team and find out that, compared to the earlier one, how much the cost saving is there, how much the energy saving is there, and based on that, we convince them, and based on that, we need to convince our customer also, and then implement it. This is how we work on this. This is the structure of the framework. Like we have an R&D wing, then we have a digital team. This is basically complete digital. Like we have a, you can see here, we have a digital twin we are creating now. All the projects, whatever is happening across the globe, we'll be able to sit in our Chennai office, and then we'll be able to monitor that. What is happening, how much chemical we are using, how much energy we are using, and what was the flow, and what was the TDS level. All that thing we'll be able to find out, and then based on that, we'll be able to optimize. That is the idea. Plus, we are also able to reduce our O&M team there at site. Now, we are able to predict, since it is all connected to the AML, we are able to predict what is the requirement of water for each plant, for individual houses, for individual team, at what time they need more water, at what time they want. So based on that, we will be able to predict the requirement as well as the what is the predictive maintenance also we do that. So we found that by doing this, we'll be able to even bring down our O&M resources. Then we have a knowledge hub team. Basically, it's a global platform for knowledge sharing, as well as we are also working with startup. So startup companies, and we also wanted to co-create some of the things along with them. This is our laboratory. Anyway, I need not explain to you. I understand that you have a big laboratory. So these are all the areas which we are working: analytical lab, microbiological lab, prototype zone, unit operation lab, desalination research lab, simulation lab. We are doing some 2-3 desalination plants in Saudi Arabia, where they are asking for bringing down the power consumption and all. So we are just looking on that, how to bring down the power consumption, how to reduce the membrane replacement. Very regularly, we need to change the membrane, which is costly, how to bring it down. Those areas also we are looking for. This is the key R&D. Basically, in addition to whatever we have an issue at site, like how to improve the existing process, we are also looking at what are the futuristic innovation we can work on. So the team there is a separate team working on this. So as I mentioned, the specific energy was one of the area where we are having a problem, especially in desalination plant. If you see that it's almost 15 years or 20 years back, the per cubic meter of water to desalination plant was around 15 unit power was required. So today it has almost come to around 3.2. So that much improvement in the process has happened. But still people are looking for further how to reduce it. So we need to do some improvement on the process. We need to do some improvement on the membrane. So we are working on that. We are also working along with your team in Dr. Kannan. Which is the place? Yeah. Pavanar. Then similarly, biological system achieving class A standard for biosolid nutrient removal. Then TDS, how to remove your chlorides, heavy metals. Then superbugs for nitrogen, phosphorus sequestration. Then chemical system right side, you can see some of the emerging contaminants like PFAS removal. Then disinfection byproduct, what is the impact on our health? We also just done some study along with the CPHO and Anna University on this. This is what I was just telling, that for a wastewater treatment, we have our own AGBR technology attached to those bioreactor. We have patented this, and this is we have done along with Anna University. And this, we were able to find out that we just compared with our SBR technology and found that we are able to bring down the power requirement by 10% and footprint requirement by 15%, and there is a surge reduction that's possible by around 20%. You can see the system which is there here. Next. This is the for the water and wastewater. For the clarifier, there is one technology on the ballast clarifier. So by using this ballast in the clarifier, we are able to bring it. I mean, it's actually available technology only. It's not new technology, but it's a advanced technology for water treatment plant. What we are looking at is presently the ballast what they are using is for micro sand. We are just seeing there are any other material which can further improve. So we are working on that so that we can reduce our dosage. We are able to bring down the footprint. The purpose of ballast itself is for reducing the size of your clarifier, because the ballast which will float along with the water, because of that heavy weight along with the whatever the suspended solid, the settlement will happen faster. That is what it's the basic principle. So we are looking at various material other than whatever is presently used, so that it will be cost effective as well as footprint reduction, dosage optimization. Those areas we are looking at. We're not going on at our WTC projects. This is what I said. We have worked along with CPHO and Anna University how to bring down this disinfection byproduct impact. So we know that disinfection byproduct is going to be there and chlorine is used. Or we have also verified that ozonation, UV, all these areas, using this also we verified what is the impact. And we found that the finding is, we are yet to finally make the report, but understanding is that there are few WTP plant which is having this impact, but many WTP plant is not having, it's all within the limit. This is the ammonia-based control for reduction of power for blowers in bioreactor of wastewater treatment. So wastewater treatment, we were using the BOD-based control so far. So we are just trying to find out by ammonia-based control whether we will be able to bring down the requirement of air, because we will be able to optimize the air requirement. So the blower air requirement we found, our target is around 10 to 20% saving, whether we'll be able to do it. That's what we are trying. We are still working on this. This is a sludge management. I understand that you are working in this area, sludge. So basically, we all know that the sludge is becoming a big issue, especially in cities. Bombay, Delhi, and all, they are finding it very difficult because there's a lot of sludge is produced and there is no land for them to dump. So many of the customer has come to us asking for some solution. So we are working on that. So one of the solution which we are looking at is converting the sludge into biochar by various process. And the objective is to prepare long-term strategy for sludge management in an environmentally sustainable, reliable, and affordable manner. Here, this biochar which is formed, we can use it for construction material additives as well as wastewater treatment application. I know that you are also working on, the NEERI is working on some of this area. We also would like to understand more about what is your work on this. Another area which we are working is the pesticide and heavy metal removal. Here also our key highlight is that in-house technology for simultaneous removal of pesticides and heavy metals. See, one is removal, another one is destruction. Because once you remove, you'll have to dump somewhere. So that will become a problem. So how to destruct, completely destruct and change. So AOP, by using AOP, advanced oxidation process, we are just working on that. And as well as adsorption technology also. I understand that I think you are also working on this heavy metal removal and these pesticides. So I think we can combinedly also see whether how we can work collaboratively. This is another one, desalination, overall energy optimization using digital twin. So we are, as I mentioned, we are already done 120 MLD desalination plant in Gujarat. So there we are using high amount of energy. So the customer wanted to bring down the energy. So we just trying this with the digital twin. So we are now getting a complete live data at our technology center, and then verifying that whether this digital twin will be able to, based on that, we are able to see that what is the TDS level, what is the pump pressure, at what pressure it's working, whether really that pressure is required. So we are studying based on this live data, we are studying that whether anywhere we will be able to optimize. And our target is at least we should bring down the energy to around 10% by 10%. then you are all aware that Yamuna, this was one of the topic even in the newspaper recently also, that Yamuna is becoming completely, especially ammonia, ammonic nitrogen has become an issue there. So the customer has come to us and said whether you will be able to do something on this. So we are working on this because the limit is around 0.5 milligram per liter ppm. So presently we have around 4 ppm there. And when they given the contract document to us, we are working on one of the water treatment plant there. So there, when they given the contract to us, they said it's only around 1 ppm. So based on that only, we completely finished our engineering and we have completed the almost about to complete our execution itself at site. But when the government has verified, they found that it suddenly is peaking to 4, 5 and all there. So they wanted a solution for this. So again come back to us asking for the solution. So Water Technology Center is working on this. So what we found is that by using a nanobubble technology, we are able to bring down. We have done this large scale. And we have also done a pilot scale there in project site itself to verify whether this is possible. So using the same water from the Yamuna, we tested there. And we found that it is possible by using nanobubble as well as nanobubble in the form of ozone, and then chlorine also being used. So being used both chlorine and nanobubble, we are finding that from 4 ppm we are able to bring it down to 0.5. So we have a few days back we had a meeting with the CEO of the Delhi Gel Board. We also informed them that we will be able to bring it down. So they are also happy that okay, there is some solution has come. Now we need to see the viability of that. This is another area, biogas enhancement. Here, as I mentioned that in most of the projects, the recent project, we are working on power generation from the biogas. So the sludge is converted into biogas and then from there we are generating the power. But what we found is that the power generated is not expected level because the biogas formed is very minimum. I can say that what was expected is much more, but what was generated is much less. So we need to work on that because even the customer was thinking that by converting into power generation, almost 60-70% of the power is taken care by this. But we found that it is not possible. It's coming around 40%. That range only is coming. So our WTC, Water Technology Center, we are working on this, how to improve that. So we are working on various methods like enzymes, using enzymes, biocatalysts, methanogens, all this, applying this, we have just applied our work in lab and we found that this is a status like we are able to bring it, and by bring it down, we are able to increase the biogas by around 10 to 15%. And this we are now about to implement in our daily projects. This is another, we are working on this carbon sequestration also. I am sure, I saw that you have done a great work on this carbon sequestration. So we are also working on this at our Water Technology Center. We'll also try to understand how you have done it and what is out. We are also finding some of the, there are some challenges are there in this. But I'm sure that we are able to able to be successful in this, especially in STP area and all, we start using this. So much of air pollution can be reduced. This is another one where we are working is a digital twin for NRW reduction. So some of the projects we are working many urban water projects where present NRW, that is non-revenue water, is around 55%, 52 to 55% is the Delhi, Pune and all, that is the status. So customer now wants to bring this NRW from 52 to around 20% is the target, 20% they have to bring it down. So we have done in-house software, AML solution, and then we are able to bring it down to 25%. Now we are also seeing that further to bring it down by various iterations. We are trying to bring it down to 20%, which earlier was taking around 3 years to come to this level. Now we are able to bring it down within 3 months. We are able to reach this from 52 to 25%. That is a big improvement we could do by using this technology. as I mentioned earlier, that we are planning to have find out various team to work with us. The startup companies, we have collected around 100, 200 numbers of startups, verifying their capability, their quality, output and all. And then we will select around 10 startups. And then we wanted to co-create the solution holding. And then we also wanted to, in our lab or our center, we wanted to demonstrate the technology as well as we want to, so we are going to fund also for this, and then the technology transfer as per the mutually agreed plan we are planning to do that. I know that you are also must be working with the various startups, so probably we can also understand from you that more than whatever startup we received, because we have got around 500 startups in water space, but we found that out of 500, almost around more than 400 is not even worth looking at it. So that there are a challenge in the startup. So now we have come to around 5 to 10 numbers. So definitely in another 1 month we wanted to do a hackathon at our places, and then we wanted to invite them, and 1 or 2 will be co-creating that. That is what our plan. So thank you for listening to us. And this is, I just wanted to show you that what we are doing, because I know that you are doing much more here. So probably this will make us understand that how we can have a collaboration and understanding that in addition to this 10 whatever I showed, 10 or 11 whatever I showed, we are doing another 10 more. There in the presently 10 more projects we are doing in our Water Technology Center. We are also tied up with many 1 or 2 big international research organizations plus various academic institutions, and we're working on that. So we also wanted to have some collaboration with NEERI, which is there in the top of, I will say, the nation. Thank you.
Thank you so much, sir, for providing such a comprehensive overview of L&T's initiative in this domain and futuristic innovation. And also thank you for showcasing how advanced engineering solutions and digital tools is shaping the future of water infrastructure in India. Thank you so much, sir. We're privileged to have you. Now, as a token of our appreciation and gratitude, I request Director CSIR-NEERI, Dr. S. Venkataraman, sir, to felicitate our guest, the distinguished speaker, Dr. K. Rajivan, sir. I also request Dr. Ganesh sir to please join the dais. Please join the dais. And I request Director sir to please present a memento to Dr. Ganesh sir for his gracious presence. Thank you so much, sir, for such an enriching and thought-provoking session. As we are moving to the end of the session, I request Mr. Prakash Kumar, sir, Senior Principal Scientist at CSIR-NEERI, to propose a vote of thanks.
Dignitaries on the dais, my colleagues, students, student associates. Sir, there was some technical problem, so I apologize. We apologize, rather.
You have to apologize.
No. But that is a lesson for us, as we heard in your speech and what experienced earlier. So that is technology. And we spoke about technology. So what was the difference that technology, because they are in sir's laptop, that laptop could not work here. So that was technical glitch here. So I think user friendly, this system which sir brought, he wanted to operate on this system, our system. But due to their policy, it could not operate. means L&T's policy. It is not our policy. So, so it is a lesson for us how science and policy should go in hand by hand. So that is why you experienced or you saw that there was some problem with us. We were moving here and there. So the laptop did not work. So apologize for that because actually sir, beginning only we should have done that exercise. But we thought that.
But you solved.
But it resolved. That is what the technology is important. Anyhow, within this short period of time, 5 to 10 minutes, we resolved the issue. So that we made some user-friendly means effort. So it was. I'm not going detail that what was done from his office and our office. So finally we did, and technology worked. So that is more important. And what we are told today that innovative technology, water, wastewater, everything. So we also need to go forward and collaborate for our betterment, for our society's betterment, for environment betterment, for everybody. So this message is clear from your message, sir, from your presentation, and we'll. I'm sure that we'll very soon collaborate on several issues which you have highlighted in your presentation. And what to say about our director? He has already pointed out that NEERI is working in so many areas. Many areas, because it is our diverse field and we are working on so many areas. And we are also going technologies, whatever we are developing, recent interventions, whatever we are doing. So it is for ultimately for betterment of society and industry, government interventions, government or judiciary. So, sir, I think in your leadership you will nourish everything you will do, and whatever comes forward, like L&T collaboration or any industry or any government or anything, so we will do that. I think on this technology day and this environment day, we should reaffirm our commitments. So that is what we have said, and we will do that. We are all with you. So thank you very much, and I will not go because because it is vote of thanks, and I should be very precise and clear. So thanks to all, because I cannot name anyone that somebody has done that, somebody has done this, and somebody should do that. I will not go. So thanks to everyone, salute to everyone. And in the end, I will just read as usual 2 lines, whatever I have written in Hindi poems. So on this day, please listen to me. If you don't like, no problem. If you like, no problem. Because it is up to you. But I will recite some poem for you. So, Prakriti ki pukar, it is in Hindi, sir. I apologize. But I think you will understand. प्रकृति की पुकार है, तकनीक से सुधार है. What technology has said, sir has mentioned. So, प्रकृति की पुकार है, तकनीक से सुधार है, विकास वही सही जो मोदी जी कहते हैं सस्टेनेबल डेवलपमेंट, विकास की मैं बात कर रहा हूँ. विकास वही सही जो हरियाली का उपकार है. नवाचार की लव से, नवाचार मतलब इनोवेशंस, लव मतलब इग्निशन, स्पार्क. नवाचार की लव से उजियारा फैलाए, उजियारा मतलब ब्राइटनेस. धरती माँ की गोद को फिर हरा भरा बनाए. थैंक यू वेरी मच. With this now I invite Devaswiji to podium for national anthem. May I proceed?
जनगण मन अधिनायक जय हे भारत भाग्य विधाता. पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा. बिंद हिमाचल यमुना गंगा उच्छल जलधितरंगा. तब शुभ नामे जागे, तब शुभाशिष मागे. गाहे तब जय गाथा. जनगण मंगलदायक जय हे भारत भाग्य विधाता. जय 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 जय. Thank you, everyone. This comes to the end of the session. I request everybody to disperse. Let the dignitaries go first, and then we go. Thank you.